I will introduce you in Portuguese, and then we have an AI translation for the audience. Então, essa é a penúltima sessão. Nós temos a Provides, a Marcela Caroni e a Camila Zinguier. Eu vou começar apresentando a Provides. Provides é designer e pesquisadora em arquitetura, cuja prática conecta cibernética, tecnologias imersivas, sistemas descentralizados e design participativo. Ela é lecturer na Bartlett School of Architecture e doutora da Chinese University of Hong Kong, aonde ela está agora, se eu não me engano, são 7 da manhã, 8 da manhã. A Provides é cofundadora de 2 coletivos internacionais de pesquisa, Current.cam e Here. Seus projetos exploram temas como a aplicação da IA no cinema volumétrico e design bioinspirado. Seu trabalho já foi exibido internacionalmente no Rijksmuseum Twente, Multimedia Art Museum Moscou, Bi-City Biennale, que é Shenzhen, Hong Kong, Athens Digital Arts Festival, UCLA, Matadero Media Lab, SciArc, entre outros. And Pro, thank you very much for joining us. The stage is yours, or the screen is yours, more precisely.
Thank you so much, Victor, which I suppose was a very warm welcome. I don't understand. But thank you so much. It's very exciting to be here. I had to wake up at 6 a.m. this morning, so hopefully my brain is working correctly. I hope you can see my screen. So to a little bit of our latest project, which is called The Scientists, and it has to do with how we turn participatory design into more anticipatory actions with real-world communities. My internet connection is unstable, so I guess environment that I was brought up, born and raised in Hong Kong, and it's an ultra-high-density city, which means that we use very little land portion and we hold a lot of people. And so this creates a very compact model that actually allows more than 70% of our land area to be greenery. But at the same time, it also draws a very thick, straight, and artificial line between culture and nature, urban, rural, and how humans actually exist within the larger environment. And this really affects what is called climate equity. It's about who is exposed to most climatic risks and who gets access to protection, resilience, investment, and learning opportunities. For instance, in Hong Kong, the Institute of Health Equity has researched that private school has up to 10 times more greenery than public school. Subdivided floods, the average temperature can get up to 40% higher than public housing. And so with these data, what we know is that greenery is equity because trees can actually help lower ambient temperature by 5 to 8 degrees Celsius if we plant the right kind of trees. And if we grow a football field of trees together with evaporation of soil, it can get up to 10 degrees cooler and more. And so if certain schools have more trees than other schools, then it basically determines who has the right to play outside for longer in an increasingly warming future. And so I was reflecting and consolidating some of the works that my colleagues at the Bartlett was doing, for instance, BioID. They look a lot at how we can use sustainable material to provide not just a beautiful wall, but also these walls have insulation property built into the design, as well as sustainable use of material. But most importantly, it's not just one wall panel. For instance, the Deep Green City from Research Cluster 16 at the B Pro 2023, they really look at how the urban texture would radically change if machines are used to synthesize human and natural landscapes. And I think these projects inspire me a lot as someone who teaches at the Bartlett, which is to think about what is the role of the architect in this very automated artificial intelligence-driven future. And so the research question becomes, how can AI tools help us to co-create ecological ideations beyond the enclave of the lab to rework communities? So ways in which we can really bring all of these thinking into real users. But before we can answer the question, we have to think about, well, what is AI that we always refer to? Well, the father of artificial intelligence, Mark Minsky, one of the fathers, back in 1961, define it as the science of making machines do things that would require intelligence if done by man. However, as my colleague Doria will say, that intelligence does not always necessarily imitate humans. Some of the intelligence that we can learn from, for instance, biological, like slime molds, who doesn't really have a brain, but it's very efficient of finding the shortest path between two near-driven sources, so it survives. Neurointelligence, we often know, like neural networks, kind of imitate how neurons synapse and process information. The science intelligence is something that we kind of forgotten nowadays, but it's so important and unique to us as humans that we're able to rationalize through tools like mathematics, physics, and embed that in the things that we create. Collective intelligence, for instance, of block words demonstrate behavior without something that's kind of like a central control, but more like bottom up. So these have been rapidly in architecture and planning. Slime molds were used to simulate project Japanese railway systems. Very efficient to find shortest path between two cities. Neurointelligence, Chalet, who was one of the first guys that applied generative adversarial network to floor penetration. Science intelligence, of course, Renaissance is one of the high points of design intelligence demonstrated for humans. But if we look across the world, we will see examples from Asian culture, from African culture, and all of these are important parts that we also have to consolidate as part of the database. Finally, collective intelligence. This is a work by also a colleague at the Bartlett, Jill Ritson, who kind of think about if we can discretize architecture component, it might benefit automation in construction. And I like more collective way of assembling parts. And so what I would focus on is to talk about how we have been experimenting with biomimicry design as a way to replicate biological intelligence within the human-machine collaboration. So we kind of introduce nature as an agency within these automated pipelines. And biomimicry is the discipline of studying nature's 3.8 billion years of evolutionary models, systems, and processes to solve human challenges sustainably. And if any one of you have seen Avatar, the latest movie, I still haven't got time yet, but I've heard it's a beautiful movie. It's even featured on National Geographic because of the way that it applied biomimicry logic to creating this marvelous world. For instance, what we're seeing here is essentially they pick jellyfish, which is hydrodynamic creatures, and put it in the sky, which is aerodynamics. And this not just create a beautiful image, but it also hints at perhaps a different way we think about air flight mobility. And this is not just some imagination, because back in 2014, scientists at the Royal Society published a paper that utilized jellyfish mechanism to create autonomous like drones that are as light as 15 grams. And they do it by minimizing drift, but enhancing lift through the jellyfish motion. And so this is incredible because it tells us that machine doesn't have to look like us, but also we don't just learn from ourselves, we learn from our surroundings. And for something as populous and as abundant in the ocean as jellyfish, we often overlook how intelligent their designs are. And I think that by learning, not just from nature, but also from movies, we need to blend real biology with makes the impossible feel plausible. And this I quote the National Geographic. And we see more and more of these applied in urban development. For instance, flock systems are now increasingly used to simulate drone behaviors. Slime molds, again, they were also used to evaluate train systems. Like this is United States, and obviously it's not the most efficient train system, but why is that? And through simulating these biological intelligences, it kind of tell us the answer. Melalin by MIT Media Lab, they use this to imagine a future kind of building installation. And this is perhaps one of my favorite projects from Australia. This guy's Graham, and he's basically a design of human body that can survive car crash. It kind of tells us that, you know, if we don't wear a seatbelt, we have to evolve to be this way in order to survive that crash. For instance, our brain needs to be suspended. Our nose needs to be behind our skulls so that it kind of gets protected. Our lungs kind of have to be this floppy, so, you know, it's insulated against like a hard crash and our ribs won't puncture our lung. And many of these biomimicry design, they can tell, they they are part of a storytelling. They kind of warn us against the future that we don't want to be in. I think that's an important part of how mitigating or building a climate resilience is that public awareness. And so biomimicry integrate biology with design, technology, geography, and science fiction to emulate nature's strategy for innovation. And that suit the project-based learning that architects has trained to be for real-world problem solving. But this sort of interdisciplinary learning is not prevalent in the current ways of education. And about 5 years, Alberto Fernandez, David Doria, Nicoletta Carastafi, and Bahao Debat, we kind of started a small thing which we call Rational Energy Architects, which is to bring all of these tech skills that we have and spread it across the world through a series of free and open to all workshops. And at the time, it was very, very much about how we can deploy machine learning systems by synthesizing it with more traditional rule-based system. And so all of the biomimicry inspiration gets translated into architecture through this sort of automated loops. And again, more traditionally, we kind of simulate sun paths, wind ventilation, and how we can turn these into data sets, like generating synthetic data set through, for instance, cell automata, which started from pixel, but then you can voxelize it and then feed it into machine learning. At the time, we were using pix-to-pix, so we can kind of enhance the whole efficiency. So this is kind of a video made by one of our workshop participants that demonstrate how this pipeline works. So the machine is learning through the pixel, and a pixel was through a data set that generated from the solar simulation. Sorry, my internet, it's best right now. Yeah, and so what we hope to achieve from this is that by turning what might require 10 hours of runtime on a computer and not efficient for architects, we hope to make it more efficient so people are willing to actually learn about the environment before they design it. And what we got from this experiment was that the same pipeline can actually give emergence to very different design results if we abstract the logic. For instance, if we apply it with different contexts, different organism as inspiration, even if we pick a site that are close to equator, but they suffer from minute differences in microclimatic concerns, we're able to use this to generate results that can be different, which I would show a little bit later. And the whole logic kind of compresses into this. So you got a series of the pixel generated, you voxelize it, and then in the future, we might be able to swap these geometrical proxies with more complicated architectural components that combine with building information modeling. And this was the result at the time that if we automata, it took 70 gigabytes per 1,000 evolutions. But if we train again, we need only 2 to 4 gigabytes of memories. With 600 iterations, we're able to train it, but we're able to generate solution instantaneously after we train the algorithm. And so what traditional algorithms are good at is that it's good at working with context with little data. So it can generate synthetic data. But with machine learning, you need to have a data-rich context. And the amount of data we get is correlated with not just the representation, but perhaps also the income of the area. For instance, before we tried to apply this pipeline, comparing a site in Hong Kong and a site in New Delhi, and we realized that a lot of the slum areas in New Delhi, we couldn't find any data set on. But Hong Kong has a scan every 5 meters. And I think that is also part of why certain parts of the world are not represented equally. And so when we do this climatic simulation, it's also not inclusive. Last year, we tried to take one of the designs and fabricate it with biomaterials. So this is fabricated with PHA, which is a biopolymer that is fully degradable under soil. And so with this installation, we hope to demonstrate that the digital reality which we have been creating has potential to be replicated in a real world, also bridging through material agency. But this is not it. We hope to bring all of these things that we've done in the past 5 years into a design scientist incubation program, which essentially not just teach university and postgraduate students, but we actually teach public school students that they can start to learn about this knowledge early on. And the whole logic works like this. We built an entity called Digital Common, and its ambition is to build a college where architects and designer gets free tech upskilling to navigate the digitized industrial landscape, but they give back to society via youth engagement. So they do social service and engage public school students and teach them how to use these tools. Then students would pitch innovative sustainable development goals ideas with a technology-driven approach to policy and decision makers. And the whole goal is to create this cycle of information that can help promote more sustainable ways of building. So we are very lucky because this is like the fifth year been trying to do, but at the same time doing all of these technology experiments. And this is the year that we see a lot of people are finally buying in. And these people are not just PhD researchers, but we actually have professional architects who are willing to spend their time. We've got former assistant director of observatory, former secretary of the environment. These are policymakers, and they get insights over how city decisions are made right now. We've got celebrities who had a background in architecture that actually support us, and we've got an international crew of mentors who are also willing to give their time in spreading this knowledge. So these are the 9 schools, high schools that we worked with this year. But not just that, we also involve local communities who will be able to input their lived experience over living in a city for more than 50 years. And this is a situation that we had to deal with in that workshop. This flooding actually happened right next to my high school a few years back. And it's actually took place in this 5-star hotel. And if we look at how the whole landscape has been planned, we started to think about, is the water really flooding the 5-star hotel, or is the 5-star hotel deliberately standing in the way of water? And that kind of changes the way we think about natural disasters. So Nabi kind of introduced the concept to us, which is called a designed disaster, which kind of says that if the environment, like the way of water, has its own path, and if we stand their way, then obviously we'll be flooded. And so it kind of tell us that it's not nature who wants to flood us, we're designing those disasters. And so we picked this, which is at Saiza Go, a very interesting site because it has luxury development, residential development, it has traditional villages, it has like oyster and fish farm, it has a mangrove wetland. So very, very diverse topology packed into a relatively small area. So this is the Go Park. I think it was designed by Sahadi architects that kind of provide a lot of physical sports area for the public. But at the same time, the villages next doors, they get flooded every year. And we've also got this beautiful mangrove that will be transformed into an ecotourism site for people to get close to nature. And the whole context is that although Hong Kong is very, very small, so we are about 0.03% of China's total marine area, but we have more than 26% of the nation's overall species. The amount of corals hard corals that we have here is the types of hard corals we have here is more than the entire East African coast. And so we rank 4th in the world for urban biodiversity. But how much of that biodiversity has been taken into consideration within current pipeline of planning is really the question. And so working with Yao Yao and Carlos, we were trying to collect all of the biomimicry inspiration that can help assist the development of the design. We also learned from Scape. They have a project called Living Brick Water, which really look at the land-water interface, how culture, ecology, and risk should be designed into the same pipeline with or without technology. And finally, breaching that with the fabrication capacity we have to recover nature. And finally, is the most in experimenting with biodegradability, biocompatibility, and tunable property for future fabrication. And through a living lab approach, we were able to generate some results, which I'm going to show you right now. Essentially, this is what we did throughout the workshop. Participants identify the inspiration from nature. They try to situate the solution within context. They design the components. They fit it within architectural topology, and eventually design by having fabrication in mind. So this is what the workshop is currently look like. And these are the 4 tutors that led the part 1 of the workshop to train the facilitators that would actually engage youth. And so this is one of the first graphics that participant generated, which essentially was from GIS that look at the area. And once we remove all of the boundary between nature and like artificial structures, we started seeing the area as a whole instead of plots of land that actually generate capital for us. And so this is one of the first designs that came out, which is look at how mycelium can help to balance pH within soil. So it will help bond soil stickiness essentially to minimize soil erosion during surface runoff when there's a huge rain. And they started by investigating how serious soil erosion currently right now is in Hong Kong, that we're, first of all, very mountainous. Second of all, if we continue to deforestation, then there's nothing that can help hold soil together. And so they started thinking, well, what if we do not build the same way that we did before? Can we diversify the way that we generate these landscape? And I think these visualizations for us, it's not just to say that like this, but really to identify the boundary between the artificial natural that happens right now and think of ways that we can bridge them together. The final design doesn't have to essentially look like this, but you can definitely see how human settlements and vegetation settlements are now completely parted. And even the aqua ecology, which is an important part here, are also neglected. And what I find very beautiful in this project is how they managed to generate the series of graphics that on one end of the spectrum is very, very artificial, but on the other hand, it started merging much, much more into nature that you can't even tell this is generated by AI to some extent. And so, a second project which looks at how we can distribute these sort of infrastructure into smaller components so it's better sized with nature, but at the same time, by maximizing surface areas of the structure, it helps organisms to rehabitat the area. For instance, if we have wetland and we want to promote cultural tourism, is there a way that we can promote it without intruding into nature? And so I think about, well, what if we can distribute the same component across different geological topologies? Can we invite human visits in a way that's less harmful? And this one is actually a project that I really enjoy. It's a team led by Wei Hao. And instead of thinking about what we can do now, he think about what we can do in 50 years. And so it kind of projected that if we let current circumstances go on, the flooding situation might be accelerated in a way that is beyond our comprehension. So like to some extent, it might even flood an entire 2-story building. And so we would need breakwaters that would be taller than 2-story. And I think this is such an imaginative feature that kind of goes back to science fiction that we saw before, kind of warn us against what we're actually creating. Like, do we want a future like this? Is this dystopian, utopian, or is just heterotopian? If this is something that would come, how do we mitigate against that? And I think now is the job for architects to not just think about how we build now so we can gain financial capital now, to think about that future in 50 years' time. Yeah, and this is one of the final outcome that I will show for this workshop. This one is much more community-centric, and it thinks about if we learn from seashells and if we want to recover biodiversity through these micro interventions, how we distribute them across a site. And so local communities, villagers would also be activated in this climate narrative. Yeah, and so these are planters that essentially integrate designs of biowells as well as diversity planters. And what it does is that it kind of acts as a sponge to absorb the rainwater and bring it underground. It also creates a very vibrant public space, integrating with village topology. So then it creates an urban activation zone where people can come together and spend their time quite nicely. And so this was one of the projects that eventually gained a design award within the series of workshops. And I think it kind of shows how the social aspect, ecological aspect, which are currently seen as two different discourses in academia, should really be brought together in order to respond to topics like climate equity. But reflecting back, these are results that were generated 5 years ago when we started the workshop series. For instance, how we mathematically compute the distribution of bioluminescent organisms so we can better distribute light sources across the city, how we can learn from algae in light harvesting so we can create beautiful pavilions that not just provide a public space, but also harvest light at the same time. How we can learn from like sea sponge to retrofit skyscraper facade and balance temperature, how we can learn from mullein and mushrooms to create urban elements that can provide shade while absorbing energy during daytime and release it at night. So those were design that has not worked with communities before. And now we really bring them to the user spaces. And in the next month or so, we will start seeing outcomes from them that not just learn from these projects, but also ground it in physical reality. So it prepares us towards the next stage, which is really a citizen architect idea that we can democratize this planning and architecture knowledge to empower them to build their own city. So this is kind of like a final show reel that I wanted to show. So Digital Commons has been trying to blend this human machine pipeline with participatory design. And how we do it within the workshop is that we bring communities together with architects, planners, and through this video gaming approach, kind of help them to understand the city by playing, like learning through playing. And of course, we've got virtual reality that allow them to look at design from user perspective, which is what planners do not do right now. And also, one of the key argument was if we're able to teach students using video game to plan designs, kind of like Minecraft, if a 12-year-old can build a universe inside, it kind of challenges us to think about, well, what is the role of designer? Is it just the ability to build something or the ability to understand needs and generate from that needs? And so we're very lucky to have a lot of partnership. Most of them are with NGOs. We consider ourselves an NGO as well. So not just in academia, but actually having an organization that operate in the real world. And in the future, we're planning to also go into the market so we can understand how this academic knowledge can be transferred into the industry. And data has validated, our data has validated, shown us that if architects work on their own, yes, they can be creative, efficient to some extent. Their attention span is actually much shorter. Performance is not as stable. But if we start introducing stakeholder into this creation process, we do see that attention span is longer, which kind of also means that we invest more time, but also the outcome are much more grounded in real world community needs. And so I think projects needs to balance its objective when they're choosing different participatory approach, which is the level the citizens engage with these projects. So these are some of the feedback from our participant, and it kind of motivates us to go forward. A little bit of takeaway from what we've learned in the past 5 years trying to do this participation. We go back to this reality that we started at, which is this compact city model that we've always built in. And if we want to change that reality, it also means that we have to change current way of decision making. So instead of only creating order, which is very artificial, the straight line, the grid, the vertical grid, essentially, we have to let data, network, agency, ecology, which forms an urban operating system. And it's not only creating order through the prediction and control, but we also need to create surprises so it diversifies choices inside this operation system. And if we turn this cone into a 3D visualization, it really tells what speculative design does and its role, which is to project the possible futures. And so architect doesn't just make one rendering, but it should utilize the power of generative AI to create many, many possible futures. So we have more choices that can inform our decisions. And eventually it's all about how designer, algorithmic models, community input, and ecological agency comes together within that decision-making process. But how that actually take place, there are different models. So this was, again, proposed by Martha Minsky. On the left side, you see a homogeneous network where there's a fixed learning or design procedures. You fit it into the artificial intelligence. It came back and you kind of judge it, critiques it, and the loop goes on, which is not bad. And it kind of is what we're doing right now. But according to this model, it's a very simple scheme, and it's not enough to fix complex planetary problem that we're facing right now. And on the right side, we see the society of agency models, which kind of say, okay, there are essentially like think tanks, like people who kind of learn through the environment. And you also need ABC brain that kind of has different logic. And then each of them will feed back and generate information also to critics. And so then you get the society of agencies and managers that balances each other's decision. And the system overall would engage in new ways to learn. And if we reflect on the role of architect, this is kind of what should happen. That designer symbolicist approach to designing should wrap around how artificial, like neural network is operating right now. And this is the idea of wrapper that we always hear. But currently, our wrappers, are they designed towards sustainable development goals? Is the questions that we should be asking. So final files kind of summarize the role of architect through this list. System designers, researchers, foresight strategists, impact visualizer, prototyper, computational designer, digital cartographer, material agency, automated construction, ecosystem strategist, facilitator, property management innovator, service designer, dataset designer, prompt engineer, community builder, ESG analyst, and so on and so forth. I do not see this as a pure specialization of roles, but it's actually much more generalist approach to architecture that you actually absorb and select these roles as you need as hats that you actually operate within a project. And so finally, we obviously want to thank all of our partners. Without them, we cannot operate and survive till today. And I think Digital Comment is a platform where we really want to welcome anyone who wants to contribute to environment, social courses to join and promote a more common way of utilizing technology. So if anyone's interested, welcome to get in touch with us, and thank you for listening.
Thank you very much, Pro.